This is day 2 of Unit 6. So we started today with a warm-up. You should pause the video, do the warm-up, and then play to check your answers. So first we want to factor. This is difference of cubes. So x minus 3 times x squared plus 3x plus 9 over GCF x squared times 2x minus 1 times difference of squares, 2x plus 1 times 2x minus 1 over, looks like no GCF. Let's take a moment to think about what that's going to factor into. We know 2x and x. We know 3 and 1, and it has to be 6 and 1 to make 5, and that's a negative 5, so negative 6 and positive 1. There we go. So from there, I can get my restrictions. Because x squared can't equal 0, that means x can't equal 0. Because 2x minus 1 can't equal 0, that means 2x can't equal 1, which means x can't equal 1/2. Because 2x plus 1 can't equal 0, that means 2x can't equal negative 1, which means x can't equal negative 1/2. And lastly, x minus 3 means x cannot equal 3. So I'm ready to look on the diagonals and on terms on top of one another. So I see 2x minus 1. I see x minus 3's. I see 2x plus 1. Looks like that's it. So my answer is x squared plus 3x plus 9 over x squared. Can't simplify that, remember, because it's not a common factor. And then just my domain restrictions after that. So x can't equal 0 plus or minus 1/2. What else did we say there? Or 3. Okay. So we started today, similar to yesterday, simplifying rational expressions, although today's rational expressions look a little different. They look more like fractions within fractions. We call that a complex fraction. We have a fraction within a fraction. So this is review. You did learn how to do this in Algebra 1. And what you learned is when you have a fraction within a fraction, it needs to be simplified. You can't keep fractions within fractions. So the way that you simplify complex fractions is by first looking at the denominators of the fractions. So in this case, 8, 4, 2, and 1 here, if I think of that as 2 over 1, and getting the least common multiple. So the least common multiple between 8, 4, 2, and 1 is 8. So once you have that with this technique for simplifying, which we call fraction buster, sometimes teachers will call it that, what we'll do is we'll multiply both numerator and denominator of this complex fraction by the least common multiple, which we already said is 8. So I can multiply by 8 over 8. Now, that's fine. I'm allowed to multiply by 8 over 8. I'm not breaking any math rules because that's just 8 over 8 is 1, and I'm just multiplying this expression by 1, which is perfectly fine. So if I'm multiplying 8 by this whole numerator, I'm going to distribute the 8. So I'm going to go ahead and write that out. So 3 over 8 times 8 over 1 plus sign 7 over 4 times 8 over 1 all over 3 over 2 times 8 over 1 minus sign 8 times 2 we know is 16. So that's helpful because I can look on the diagonals and cross off common factors. So now that I've done that, I have 3 times 1, which is 3, plus sign 7 times 2, which is 14, over 3 times 4, which is 12, minus sign 16. So I can simplify that very quickly into 17 over negative 4, or negative 17/4. That is my answer. Okay, this approach, by figuring out the least common multiple and multiplying numerator and denominator by it, is the most efficient way of simplifying complex fractions. Oh, and actually I want to go back a moment. So when we're on this step here, we have the 3 plus 14 over 12 minus 16. If you find yourself writing fractions here, if any of these terms are fractions, then that means either in the previous step you made a mistake in your simplifying, or what you thought was the least common multiple actually is not the least common multiple, because the least common multiple, if you multiply terms by it, should get rid of those common factors, and you should always no longer have any fractions at this point. So again, if you have fractions in any of those spots, you know your LCM is not correct, or you made a mistake here in your multiplying or simplifying. Okay, so next one, you want to get that copied into your notes. So now we have variables involved, but the process remains the same. So what we're going to do is we're going to look at the denominators, x, 4, x squared, and 2x. If I think about the multiples of 2 and the multiples of 4, I know that 4 is the least common multiple. Between the variables x, x squared, and 2x, really I'm comparing x and x squared. I know that my multiples of x start off x and then x squared. X squared starts off x squared and then further on. So the least common multiple between x and x squared is x squared. So that means our least common multiple is 4x squared. So I'm going to multiply both numerator and denominator by 4x squared. So once again, I'm going to take time to write that out. 3 over x times 4x squared over 1. Minus sign 1/4 times 4x squared over 1, all over 3 over x squared times 4x squared over 1, plus sign 5 over 2x times 4x squared over 1. Okay, so we have each one of those times 4x squared over 1. And now we're going to look on the diagonals and cross off common factors. So I see x and x squared become 1 and x. I see 4 and 4 cancel out, factor out. I see x squared and x squared factoring out. And I see 4 and 2 becoming 2 and 1. And x squared and x becoming x and 1. So now that I've done that, I'm ready to simplify here. I have 3 times 4 times x, which is 12x. I have a minus sign. I have 1 times x squared, which is just x squared, over 3 times 4 times 1, which is 12, plus sign 5 times 2 times x, which is 10x. Again, at this point, you should no longer have fractions, just the one large fraction, but not fractions within fractions. So now I'm noticing as I'm writing these that these are factorable. So if you can factor, you should, because there might be a common factor between numerator and denominator. So I'm going to factor out the GCF here. Looks like a 2 there. And nothing does simplify, but I still have it as factored as I can. And I'm going to, that's not my final answer, because remember, we talked yesterday about if there are variables in fractions, you need domain restrictions. So I'm going to go back and look at the original 4 denominators, and I realize by doing that, that x cannot equal 0 is a domain restriction. Secondly, I want to look at my final answer, the denominator from the final answer, and I want to set that not equal to 0 and solve. So if I divide both sides by 2, I'm getting 6 plus 5x cannot equal 0. Subtracting 6, 5x cannot equal -6. And last, dividing by 5, x cannot equal -6/5. So I'm going to include that as well. Okay. So nothing else to simplify or factor out. We have our domain restrictions. We are finished. Next, copy that one into your notes. And in class, we first just talked about what would the least common multiple be. So take a moment, look at A, 5B, 2A, and 1. Think about what you think the least common multiple would be. Okay, so hopefully you came up with 10AB is the least common multiple. That is correct. So we're going to multiply by 10 AB in both the numerator and the denominator. And in class, once we came up with that, then I gave students time to work. So you might want to pause the video and try this one on your own and see if you're able to come up with the correct answer, and then of course play and check your answer. So if I'm multiplying everything by 10ab, I have 3 over a times 10ab over 1 plus sign 7 over 5b times 10ab over 1 all over 1 over 2a times 10ab over 1 minus, this is 2b times 10ab, that's 20ab squared. So looking on the diagonals, I see A and A. I see 5 and 10 becomes 2 and 1. I see B and B. Here, 2 and 10 becomes 1 and 5, and A, and nothing else to simplify. So I'm ready to multiply. 3 times 10 times 1 times B gives me 30B. Plus sign. 7 times 2 times A times 1 is 14A. Denominator 1 times 5 times B. Looks like that's it. Yes, 1 times 5 times B gives us 5B minus sign 20AB squared. So this one's similar to the last one. We see some factors we can factor out here. Looks like a 2 in the numerator. Looks like a 5b in the denominator. I lost track there when my pen stopped working. So 1 times 5b and 5b times negative 4ab. So negative 20ab squared. Yep, that looks good. So it looks like factoring the 2 and the 5b out didn't really do a whole lot for us. No common factors to cross off. But now we can get our domain restrictions. So looking at the original denominators, a, 5b, 2a, and 1, we can see that both a and b can't equal 0, again, from those original denominators. Now, setting my final denominator not equal to 0 and solving gives me 5b can't equal 0, which means b cannot equal 0, which we already knew. And 1 minus 4ab cannot equal 0, which means 1 cannot equal 4ab. We had one similar to this yesterday, remember, with the 2 variables, and I said, I don't care which variable you pick, but solve for one of the 2 variables. So I could either solve for a and have 1 divided by 4b cannot equal a, or I could solve it for b and say 1 divided by 4a cannot equal b. Either is fine. You do not need both, but you need one of those 2 to include with these other 2 that we already have. I'll write both of them, but again, you only need one of these 2. And there we go. That's our final answer. So tonight you're going to do pages 2 through 4. On page 4, you may skip these 2 problems, but do the rest of the problems on pages 2 through 4.